Alright, so we're going to talk about solving systems of equations again, but this time we're going to use something that's called Cramer's rule. So Cramer's rule is an alternative method to solving systems of equations. Most times in Algebra 1, 2, teachers don't teach you this, but Cramer's rule, it essentially calls for you to use matrices and something that's called a determinant. And a determinant is, for the most part, just a solution to how you solve a matrix. Now, let's take a look at what a matrix is. A matrix is simply, uses some brackets here, and it has some elements in it. Okay, these things were called elements, is A, B, C, and D. Okay, it has rows, it has columns, and matrices can be as big as you want them to be or as small as you want them to be. It doesn't make any difference whatsoever. Now, they could be 3 by 3, they could be 5 rows and 10 columns, whatever. But for the most part, we're just going to use these little, what we call 2 by 2 matrices. Now, matrices have values to them, okay, and we're going to talk about this thing called a determinant. A determinant is simply the value, okay, that we get from something that is like this matrix here. And the way you discover, or the way you solve a matrix, is you're going to go through, at least for us, because there's a lot more to it than what we're going to talk about, but for our sake, the way you do it is you're going to simply multiply a diagonal, so A times D, you're going to then subtract, and then you're going to do B times C. Okay, and then that will get you what we call the determinant. Okay, so let's just do a real simple example here. Okay, so here, I have this matrix. So what I'm going to do is I'm going to do 2 times a half minus 6 times 5. So obviously 2 times a half is 1, 6 times 5 is 30, so I get negative 29. Okay, and that's it. If you know how to do that part, then you can do Cramer's rule. Well, Cramer's rule says that if I have this matrix, or pardon me, this system, you notice it says AX plus BY equals E, CX plus DY equals F, where AD minus BC doesn't equal 0, which we'll talk about here in just a second, then this is true. The x-coordinate, the x-coordinate for our solution is created by this matrix over this, and then this one is created by those two matrices. Okay, so that seems kind of confusing, but let's kind of break it down a little bit. Okay, if you notice, now I'm just going to kind of rewrite what it says. Okay, a couple things to notice. One, the bottoms for both these are exactly the same, and they're just created by the coefficients of the variables. So A, C, B, and D. And then the tops, what you're doing is you're going to, again, rewrite the BD. But when you're looking for the x coordinates get replaced with EF. And then when we're doing the y, these are the same, but the y coefficients get replaced with EF. And then that's it. You've solved the matrices on top and bottom, and you'll get your solution. So let's give it a shot. Let's try one. Okay, so let's say we have this one. Okay, so let's go through and let's just do x. Okay, so the bottom is easy because it's just going to be all of these, so it'll be 6 and 1, 7 and negative 1. The top, the x's get replaced with negative 9 and 5, and the y's are 7 and negative 1. Now, what you'll see sometimes is this. This top part of the x is called d of x, or I guess it's called find the determinant of x, if you will. Okay, so let's solve. So I'm going to multiply negative 9 times negative 1 minus 7 times 5. The bottom, 6 times negative 1 minus 7 times 1. So it's 9 minus 35 over negative 6 minus 7 negative 26 over negative 13, or 2. Okay, so the x-coordinate for this is 2. The y-coordinate is easier because the bottom here is the same. Okay, we know that the bottom's going to come out, okay, since we did it just up here, it's going to come out to be negative 13. So you don't even have to do that bottom part. The top part, the x's are still there, 6, 1, but then the y's get replaced with negative 9 and 5. So let's cross multiply. 30 minus negative 9 times 1. So it's 30 plus 9 over negative 13. 39 over negative 13 equals negative 3. So there you have it. There is the solution to my system using Cramer's rule. Now, one of the reasons why Cramer's rule is kind of nice is because you come across like a problem like this, where solving that using substitution or graphing or elimination, that would be a real pain. Okay, but with Cramer's rule and a little bit of calculator work, it's really not that difficult. So let's give it a shot. Let's set up our x and y values. Okay, so our x values, the bottom, 2.3, 4.1, 1.2, negative 0.5. Okay, you got to make sure you remember that minus sign. The top, x's get replaced, 2.1 and 14.3, and then 1.2 and negative 0.5. So if I multiply 2.1 times negative 0.5 minus 14.3 times 1.2 over, on the bottom, 2.3 times negative 0.5 minus 1.2 times 4.1. Alright, so let's take out the calculator, do all this. So up on top I get 1.05 negative minus 14.3 times 1.2, 17.16 over 2.3 times 0.5 negative, so negative 1.15 minus 1.2 times 4.1, which is 4.92. So let's subtract all that. 1.05 negative minus 17.16. So we get 18.21 over 1.15 negative minus 4.92. 6.07 negative. So we have two negatives there. So let's just hope those can't. Let's see if they divide in evenly. Okay, yeah, and it comes out to be 3. Well, that was nice. So the x-coordinate is 3. The y-coordinate, again, should be easier because the bottom we already know. Now we'll set it up again. So the bottom is 2.3, 4.1, 1.2, negative 0.5. The top is, the x's will stay. The y's will get replaced. So the bottom, we already know, is going to come out to be negative 0.607. Oops, not that. Negative 6.07. The top, let's set it up. 2.3 times 14.3 minus 2.1 times 4.1. Okay, let's break out the calculator again. 2.3 times 14.3. Okay, so 32.89 minus 2.1 times 4.1, 8.61 divided by negative 6.07, and let's finish it up. 32.89 minus 8.61, divide that up by a negative 6.07, and we get negative 4. So a lot of ugly decimals there, but I would not have liked to have solved that by using substitution or elimination method. Okay, and there you go. That's Cramer's rule. Now, one thing I did forget to mention is I did mention that the top we tend to call d of x. The bottom, Okay, when we talk about the y-coordinate, this top right here we often call d of y. Okay, so I meant to mention that earlier. So there you go. There's Cramer's rule.